and you have a lot of sensitive data with you. You have credit card information, you have personal information, and a lot of sensitive data. While moving to the cloud, what do you think your biggest apprehension is going to be? Anyone, just raise your hand. What do you think would be the biggest apprehension if you're in the banking sector that contains a lot of private data? I don't even need a mic. I can hear so many of you saying the right answer, security. So as we move to the cloud, security is of paramount importance. You know there's a lot of sensitive data. There are customers who trust you with that information. And as we adopt AI/ML, or as we teach machines or train machines to get predictive results for us, it becomes very important for us to remember the security aspect of it. So with this, I'm going to call our next speaker, Joinal Ahmed, who is an AI consultant at Google Cloud, and going to talk about how to secure your workloads while adopting AI/ML. So over to you.
Thank you. How's everyone? I think before I start, right, we should clap for everyone to make it here on a Sunday with a rainy Sunday. So clap everyone, please. Hi, I'm Joinal Ahmed. I'm an AI consultant, Google Cloud Global Delivery Center. I manage some of the large AI projects there. Before you start, right, how many have us used machine learning in our day-to-day lives, right? How many have encountered machine learning use cases in our day-to-day life? Almost everyone, right? Right from what we order from Zomato, Swiggy, to what we wear, what we order from Myntra, to even reaching here, right? Maps and everything, right? Everything uses machine learning, right? And with that, right, let's look at AI market in general, right? How AI is growing, right? You know, there's this report from IDC which says AI spending in the companies will increase AI spending to upwards of 200 billion by 2025. A lot of companies who were building models into their test systems, were trying out things, now have started actually looking at how they can productionize them, right? How they can take this model and put in our hands, right? How we can use them, how they can drive business values out of them, right? And I think a lot of companies, right, this is a report from Deloitte, and they have surveyed a lot of people, and they said 57% of AI companies see that AI can transform their businesses going forward, right? So why we are looking at this, right? And while we look at this, there are certain security challenges which are there in machine learning, right? To start with, we have seen DevOps, right, how that world has grown. And we have also seen a lot of security issues that has happened, right? I think yesterday or day before yesterday, there was a news, I'm not taking the name of the company, but there was a huge data breach which has happened, right? And there are, and the best practices around machine learning security is still being talked about, right? Few years back, we were talking about how we can build machine learning models, how we can actually use machine learning into our businesses. A couple of years later, I think around 2020, 19 or 20, we started about talking about ML ops, right? How we can actually take these machine learning solutions and work at scale, right? How we can actually do the whole life cycle at scale. And recently, with the shift has moved to the security challenges of it, right? The things that we are going to talk about today are technical, but it also boils down to people and operations, right? How we operate, how we do things, how we perceive things, right? And we also acknowledge the fact that we cannot make a system unhackable, right? But we can do all of our things that we can do in our hand, right? I mean, people can just break this door and come in, but we can at least try to put a lock there, right? We cannot keep it open, right? With that, what is machine learning SecOps, right? ML SecOps. So it is basically a combination of DevOps, security, and we look at it from a lens of machine learning, right? What are the security challenges which are specific to machine learning, or what are the specific to machine learning world, and then try to mitigate them from start, right? These are the two people or the course that I like to quote, right? So starting with machine learning models, right? We should start treating them as an intellectual property, right? These models can, if gets into wrong hands, it can actually create devastating effects on the business. And the second is, I think, machine learning models, right? They get stale, corrupted, or if they are tampered with, right? The results can be terribly wrong, right? Starting with company's brand image to leaking of personal information to a lot more things that can happen, right? everyone is aware of this, right? The whole machine learning life cycle, right? How machine learning is deployed, right? We start with either training a model in cloud, in our own machines on premises, where we take the models or a custom code, combine, push it into a production microservice, and from where any REST or gRPC APIs can actually talk to these machine learning models and start using them, right? We put our all matrices so that we can capture, we can see if the machine learning models are working properly. We can also monitor if there is a data quality which is degrading, if the model quality is degrading, right? And we request, we store all the logs so that we can do all this post processing later, right? Look at this picture, right? Here we see that this is the whole life cycle of the machine learning models, right? And everyone is quite aware of that, right? We start with cleaning the data to feature engineering, then try a bunch of models, try a bunch of experiments to see if all of these models are working. And once we have a model, then we go ahead and start deploying them either on a cloud or an edge environment, right? We then log for monitoring, we look at models performance, and then the whole cycle continues, right? So one open question to everyone, right? Where do you think we need to put in security considerations or these guardrails so that we can secure our model, our intellectual property? Anyone? Please.
Primarily in the data preparation stage and perhaps in the rollout.
Okay, data preparation, rollout. Anyone else? Take a wild guess. Yeah. Data ingestion? Can you give him a mic, please?
You don't want attacks which are intentionally provide you data to corrupt your model.
So you're saying maybe data ingestion phase somewhere there, right? Okay. Anyone else? So we have data ingestion. I think this gentleman talked about deploying and other aspects of things. Anyone else? Actually, we need to secure all of the steps. We need to look at each of these steps. What are the various security considerations in each of the steps? What we can do at each of these steps, so that we at least have a good night's sleep, right? Things can happen, right? Things can happen, but we can make sure that we had done our part there. So let us look at each of these. I'll not talk about all of the things here, but we'll look at certain examples, and then the world is open to you to explore other security considerations, right? So in this session, since we have almost 25 minutes, we'll talk about what are the considerations that we do have in loading model artifacts, access to the model, what are the different code vulnerabilities which are there, what are the dependencies, right? We download all of these packages from the internet and we start using them, right? What are the security issues there? And what are the security issues in model itself, the runtime environments, the VMs, and other aspects, right? How many have used pickles to download models? Don't shy, put your hands out. Let's stretch our hands. Yeah. So there are certain issues with downloading these pickle models, and I'll show you. And I hope when you go back and when you download a new model, you'll actually think about whether I should load it in my system or not. A simple model, right? A simple scikit-learn model. And our Hello World machine learning program, right? We all have trained this IRIS dataset model on a logistic regression model, right? So starting with, we have trained the model, we have saved the model, and we use job leave. Everyone uses job leave to actually dump that pickle file, right? So we are going by the book till here. And what we do next, so let us look at that model pickle file in detail, right? What is actually in that file? So there are a lot of gibberish, right? There are a lot of things which we don't understand, but if you just simply download that file and open, you will see this model itself says it needs scikit-learn.linear model to logistic. So you can understand, okay, this is a logistic regression model. This is a multi-class classifier. And there are a lot of NumPy data which needs to be loaded for the model to run, right? There's this function in Python, __ reduce, which is called internally for Python or scikit-learn to understand what should I do with this pickle file. You just call joblib.open model.pickle. Now what should I do with this pickle file? So this is a function which is called. So we are simulating a attack here. So basically what we are doing is we are changing that function, and we just transform that saying whenever this function is called, run this command. And what is this command? Command export my environment to a text file. Okay? And I do same thing, right? I just reload that file, I do a dump, and I with open job leaf, and I open that file, right? Now what happens when I open this file again? The whole this pickle file has actually transformed to this poisoned pickle. We call it as a poisoned pickle. Now whenever you load this model into your system, this will export your environment as a text file. You can also write code here which will just capture your cloud credentials and mail it to the attacker, right? It can run anything in that, right? So you could just, this is just to simulate what can happen with that model, right? So what can people achieve with poisoned pickles? And if you see, if I open that file, it actually exported my Conda environment into a text file whenever I have loaded this model. So first step, be aware whenever you download a model from the internet, be aware, try to be at least download it from a trustable source, right? Download it from someone you can trust, a company you can trust. Don't download it from any random place, and try to think, okay, this will make my job easier, right? I'll just submit this and okay, I'm done with my work. Don't do that. A lot of ML libraries are exposed with this vulnerability, right? Starting with popular, right? Scikit-learn, PyTorch, even an older version of TensorFlow was affected by this. So be aware of how you are exporting, importing models, how the supply chain of model works, and there could be any attacks that can happen to you, to your organization, to your company, right? And that can leak a lot of vulnerable information outside. So yeah, what we can do, right? Have a trust or discard mechanism, right? Have a mechanism which you can actually vet on the source of the model, so vet on the source of that file which is coming on, right? And based on the mechanism, select. So in the start I said, right, these solutions can be technical, but this involves people and process, right? So we need to also make sure that these peoples and processes, we are following good patterns, we're not going out of the line, and we secure our environments. Second, there's something in the world called as adversarial attacks. So you don't actually, the first one we talked about when you have physical access to the model, right? This one you don't need access to the model. You just have an endpoint, and you can exploit that endpoint with dumping random noise to that endpoint, right? Random load points. And when you do it at scale, you'll actually understand how that model works, right? You'll actually try to you'll be able to actually understand how that model works, what is the architecture of it. And when you can do is, you can then actually plan a man-in-the-middle attack. So imagine from your app, users upload an image. Users to that image, you just add a noise. Everyone understand noise? You just add a noise and you send it back, right? Send it to the client. Now what happens is, when you added a noise, this horse, the model which is predicting this image as a horse, has started predicting as a dog. And a lot of this can happen, right? So what you can do, right? Secure your VPNs, right? Have security guardrails in place, right? Secure your infra, secure your code, secure your model. Implement role-based access, right? Don't open your whole environment to everyone, right? If a developer, right, a cloud architect needs an access to the infrastructure, give him that, right? Don't give him access to your DBs. Don't give him access to other aspects of it, right? So implement role-based access, team-based access, and authenticate every user, every inference request which is coming from who is requesting that inference, which client is requesting the inference, have budgets as placed, right? Okay, this client can only maybe call this model for 100,000 times. If it's more, I'm going to stop that, right? Have the securities in place. And there is this paper which was, I think, released somewhere around 2020. And they were actually able to generate a large chunk of data from that model. There was a language model. They did the same attack, and they were able to generate data. Now think of it as, somewhere a bank or somewhere other, right? And this could actually expose some of your critical, PII information, right? If people can actually execute these attacks, you would be able to, your company would suffer a huge data breach. Yeah, there are certain code vulnerabilities which are there, right? Maybe like Anuv said, right? Which one runs faster, right? But there could be certain code pieces which opens backdoor entries to a couple of things, right? So have a look at that. And there are a lot of open source tools such as GitHub provides this vulnerability scanner. you can actually run this to your code and see what are the various vulnerabilities which are there and try to fix them all one by one. Yeah, the same attack, I think a older version of TensorFlow was also having that you can actually package a code as a model, and then you can export, you can distribute it among, right? There are certain dependency issues, right? We all, let's say, write, import scikit-learn, right? But we never thought what are dependencies scikit-learn have, right? That's first level, right? Or maybe there could be dependencies that the dependencies of scikit-learn could also have certain dependencies, right? So you as an attacker, what you can do is you can actually, have a malicious package published in PyPy and add it as a dependency to scikit-learn. So whenever you just go, you are on a happy day in the morning, you are going, opening a VM, pip install scikit-learn. And that way, that malicious package is also installed. And this is, I'm just not making up, right? This is a supply chain issue which has happened, right? People, and a lot of these packages were exposed because of these issues. So don't download, and what you can do is basically maybe, don't upgrade or download packages dynamically, right? Have a trusted mechanism, maybe, have a baseline image that you use always, right? For a company, you specify, okay, what are the packages I need? What are the dependencies? If I don't need, remove them. Have a clean image and use those Dockerized containers for a new projects, right? Don't just open a new VM, new container, install everything fresh. Have everything vetted by people, your security operations team or other people who can actually vet on this package that you're using and use that, right? Track and dependencies, track your deprecations and update them whenever you can, right? Have a maybe monthly job which runs and gives you a report saying all of these packages have deprecated. Do you want to upgrade it or not, right? There are certain tools which you can use, right? First, for example, this piprot, right? So if you run piprot and you're passing your requirement to txt, it'll actually say how many days your packages are out of date. And you can actually take this information, go back and update your systems, right? There's this package called safety check, right? It is actually, and everyone knows about CVE, right? The security vulnerability report. So actually when you run this, it'll actually say, for this example, NumPy 1.21, which was installed in my system, is exposed to CVE ID 44717. Now, if I upgrade this, then I am not exposed to that security vulnerability, right? So do these checks, upgrade, have vetted mechanism in place. Same, right? You should also be scanning your images, right? Your container images. Don't think that everyone is good and everyone on the Docker registry have published clean images which are free of vulnerabilities, right? Have a check yourself. Have a see what images that you are using are free of all of these vulnerabilities, and then use them on your systems. And like I said, right, there are certain other security considerations that we need to check. Right from how do we encrypt our data, our artifacts in transit on our systems, have authorization in place, authentication in places, right? And consider this infrastructure hardening conditions maybe inside VPNs and other aspects, so that you make sure that whatever you are running is safe. You have a lock at your door. And we all know about this OWASP standards, right? Every year they publish top topics on security areas, right? So we have a similar standard for ML SecOps environment. So we just map, right? These are the top considerations that you have for your system. You should look all your systems from these lenses, and then try to see if you can secure all of them or not. Thank you all. If everyone asks any questions, I'm open.